Hello, everyone. I want to get going on strings, or C strings as they're often called, in C. And before I get into it, though, I want to give sort of a preamble of what we're about to do. Remember when we first started off at C, I said, well, there's no real good way to start with a language. We can do the overview of all these various things. I want to sort of do the scattershot approach just because you're going to see some of this stuff along the way before we get to deep dive into it. And so it felt like we covered a whole lot of material, and maybe you didn't like that, maybe you did, but that's the best I could think of for covering material for people that have never seen C or programming code before. So we went over a whole lot of different things all at once, and then we went into the nitty gritty details later. So then we looked at for loops and conditionals, and we looked at functions, and we looked at structs. Now we're going to get to strings, pointers, and memory, and a revisit of arrays. And we're right back to the same place we were last time, where you can't really talk about any one of those things without talking about the other three. Because if you cover any one of those things, essentially you need to know what arrays are, what pointers are, and how everything is stored. But you do, but you don't, and maybe we can use this as an example. So we're going to look at C strings right now. They are just an array of characters for the most part. But then we're going to get to all the little nitty gritty details and what it means to pass in a string. Because you don't actually pass in the entire string. You pass in what's pointing to the string, the location where the string is in memory. So when we get to strings, as we're getting to strings, you'll see these. There's a lot of times I may have to just do a little bit of a hand wave saying, oh, we'll get to that later. So we will get to that later. I just want you to be well aware of it before we get into it. Number two, though, we are not doing C++ strings, string objects. That will come next class, or next course, I should say. For BIT1400, we can finally start talking about string objects because they're objects. So if you decide to put in string objects in your code for the assignments or for the exam, that is going to be considered wrong. I want you to use C strings, arrays of characters. You should be able to use both of them when you're finally done with 2400, but we want to only do pure C for this course right now. So that's the preamble. I just like pointing this out. It may not be as obvious as it was in previous terms, but sometimes I give hard assignments and people go, oh my gosh, it's completely unrealistic what he's asking me to do. And I go, well, you need to be able to do it. And I'm very, maybe saying draconian, or a dragonian. But I hope you don't think of it as that. Because although I might seem like I'm being callous about the difficulty of some of your assignments, the fact of the matter is you need a lot of practice to be any good at this. And what we're trying to avoid is the following. Hopefully we have it. There we go. Does anybody recognize this fellow? I always forget the country where he was supposed to be representing, but this is Eric the Eel. He essentially paid for his own way to the Olympics. I'm very impressed with him as a person, not as a swimmer. He paid for his way to the Olympics, not a particularly good swimmer, but no one else was representing his country, so he was able to qualify. And when he did his race, everyone else disqualified in his particular heat. And so Eric the Eel, who can barely swim, if you look at that time there, that's a minute 43. The actual world record is 48 seconds. And he's not even done yet. He almost was 2 minutes doing it. Eric the Eel was barely able to get past the finish line in what is one of the shortest races in swimming. And effectively was not all. It was impressive that he was so determined, but not impressive in his actual ability. I do not want you in this position here. This is what I'm trying to avoid. I know what the bar is. I know what every one of you are going to be expected to be able to do when you pop out. If you are not able to be up to a certain level, you don't have to be an Olympic level athlete, but your fat, out of weight, and old professor can swim 100 free faster than this. Honest to God. I was a competitive swimmer. I'm not anymore. I'm really out of shape, but I can swim 100 free better than this. Right? You should not, the person swimming in the Olympics should not be swimming slower than your fat old professor. Similarly, you may not need to be the best programmer on the planet, but you need to get up to a certain bar. And if you don't, you embarrass yourself and you embarrass our class. You embarrass the people, the entire school. So I know where you need to get to. I know what your future courses are going to look like. If you think I'm being unrealistic, I'm not. I know what you're about to get into. And if you don't do the practice now, you're not going to pass the courses later. I know what 2400 looks like. I made it. So when you get to BIT 2400, it's going to be more challenging. And you're going to layer challenges on top of that and challenges on top of that. If you think this is the last you will see of a pointer, you are sorely mistaken. So I want to be very, very clear about this. The reality is you have to reach a certain level of proficiency in order to keep going. Not for my course, not because I said so, but because I know what the industry is asking from you. And it is not, what is an integer? It is, actually code this. Every single one of my interviews at any tech company, every single one of them involved coding on a whiteboard. And far, far more difficult questions than we are covering in this class, 2400, or any other class you're doing in your degree program. It is what the bar is. So we need to get you up to that. Okay. So I was also proud to say it doesn't reflect you guys. It doesn't impact you guys. But I know when my BIT 2400 class finished last fall, so they finished my course and they went off to the game development course immediately afterwards. And it was, David too was very proud of the fact, or very happy with the fact, that his second year programmers coming into his class were at par, if not better, than the fourth year programmers that came in for his fourth year version of the same class. He had a more advanced versions of game development course, but because they got through my 2400 class, they were able to hit the ground running for his class. We need you up to a certain speed. When you get to Wei's class for data structures, she's going to be hitting you with more complicated concepts. So we need to get you up to speed here. Okay, so we're going to look at strings in particular. We're going to refresh our memory what the heck a character is, looking at those again. And we're going to look at how understand input and output functions work in relation to strings, what these built-in string functions. Heck, we'll reinvent some built-in string functions. So, just a quick reminder, a character is 1 byte of memory. It's one of the few things we cannot guarantee for all time that this is the case, but for the most part, effectively, yeah, it's guaranteed. It's one of the few times they have not actually changed the size of this thing. Integers have gone from 16 bits to 32 bits. Characters have stayed at 1 byte. It is 1 byte because they are representing ASCII characters. They are encoding letters of the alphabet, the English alphabet, and predominantly aimed at American or American English, I should say, maybe with some other little accents and characters, but not much more. It's aimed for North American audiences because it was never designed for the rest of the world. It was designed for Americans to be able to do it back in the 60s, and then when the Cold War was in full swing and they needed to communicate with the Soviet Union, they needed some way of encoding a message with numbers, with a computer. Oh wait, ASCII. That's the reason it's so ubiquitous everywhere. It's not because English is trying to stomp on other languages. It's because we didn't want to be blown up by nuclear bombs for all intents and purposes. So ASCII is what we're using for this. If you want to print something to the screen, you should be using Unicode. But this allows us a small, simple way of doing text strings in our programs. It just helps us out. Each character is 1 byte of memory, and for example, the number 67 is used to represent C. So if I have character letter, if I make a character named letter, and I set it to the value C, this in memory, it is the numeric value 67 in binary. The reason this is important, so this is using a cout statement. This is from the textbook, so please don't bash me too much for having cout statements in here. But if I have a character A, I can output the character A. I can output the character B. Fine. It looks like text, right? It looks like a string, but it's not. It's a single letter. I cannot do more than one letter with just a character. I need an array of characters. So just to be very, very clear here, each character has a textual alphabetical value, and so ASCII is the American Standard Code for Information Interchange. I will have letters of the alphabet, both uppercase and lowercase. I will have symbols like plus, multiplies, that sort of thing. I will have numbers 0 to 9. I need to be able to have text messages, and that's what our way of doing it. And so I also need non-visible characters like carriage returns, like tabs. And so a space is actually the numeric value 32. A 0 as a character is actually the number 48. It's not 0, it's the numeric value 48 for the character 0. The character A is 97. I have between 0 and 255, and 0 is actually being reserved. So essentially I have 255 different characters I'm representing with ASCII. This is single quotes. This thing right here. Single quotes. Double quotes is a string. It's a completely different beast. So if I double quote A, it is not the same as single quote A. It is actually an array of characters, and you only visually see one of those characters. So it's not even it doesn't even look like the same as the data structure goes. So when we look at strings, it will look very different than this. Okay. So quick, I need you to all memorize all of these, so you can go off the top of your. No, I'm not going to ask you to memorize them. In fact, this is the reason why you have cheat sheets, but don't put this on the cheat sheet. That would be stupid, right? Just to have a quick. We'll look at this in more detail later, but the key thing is, look, I go A, B, C, D, E, F, G with decimal numbers 65, 66, 67, 68. They're in numeric order for the letters of the alphabet. The order of the alphabet is also the order numerically. I have the same thing with lowercase a, starting at 97, going all the way up. My number characters start at 48 and go up to 57. They're in order. They're logically positioned. So I can do little tricks. I can do things like, what is uppercase C minus uppercase A? Well, that is 2. The difference between the letter C and the letter A is 2. Or I can say, I want the 5th character of the alphabet, so I take A, I add 5. If I count A as 0, right? 0, 1, 2, 3, 4, 5. That's F. The character A plus 5 gives me the character F, right? It allows me to do math with my alphabet, which is kind of quirky. So again, I have values between 0 and 255. I got 31 control characters. I got a whole bunch of numeric symbols and the like. That's 32 to 64. So 32 to 64 is right here. It is exclamation point, quote, a pound sign, dollar sign, Okay. Then I have English letters with some symbols intertwined. And then I have the other stuff. And the other stuff no one ever uses as a general rule. As soon as you get into this other stuff section, which we'll show you in a second, it's past this. When you get to the other stuff symbols, at that point in time, you might as well just be using Unicode. In fact, you should be using Unicode for anything if you want to actually present this to anybody that's not another programmer. If you're trying to make a message to a user, you should be using Unicode, because when you migrate over to doing your game or your application in Mandarin, you need to have Unicode, so you might as well set it up right away. Unicode actually is variable in length. We're not going to get into the gory details of it. It's a lot more convoluted, but different versions of Unicode, one of them UTF-8, has variable length, so that if it's an ASCII character, it stays the same as an ASCII character, and as soon as you get to like Mandarin, a symbol in Mandarin, you would actually have you'd actually use maybe 2 bytes of data to represent a Mandarin character, or part of a Mandarin symbol. Sorry, I don't speak Mandarin or write Mandarin, so I'm not using the right terminology, but you understand what I'm trying to get at. Other languages have radically different ways of representing things on the screen, and they need to all be supported. Unicode actually does that. So here is a more zoomed in version of our ASCII table. Notice 0 is our special one. It's the null character. It is the numeric value 0. By the way, it is also represented as that we'll get to in a second. The null character is something special that we need for our strings. But again, here is the character 8, which is A, which is 65. Character C is 67. It's only 2 off. C is 2 characters after A. And so I can do really cool things with this. If I want to go from uppercase A to lowercase a, I just need to do some math. In fact, I don't need to memorize things. If I want the letter G as an ASCII character, what do? I figure out the difference between G and A, the character G, the character A. What's that numeric difference? And that will tell me what letter of the alphabet I'm on. Or I can say, if I have a bunch of numbers here, if I want to do math with characters, like the character 9 and the character 6, the character 9 minus the character 6 is, I can actually just do the character 9 minus the character 6, and it will give me the value, the numeric value 3, which is what I would expect. If I want to convert it back to a character, I say, if I want to have the character value for 2, let's say, what do? I say the number 2, like the integer value 2, plus the character 0, which gives me the character 2. I can do all sorts of really cool things, and a lot of really smart people have thought through a lot of these. I'm not saying I invented that. And this is when we get into the nosebleed section. Like, look at this stuff. Like, I don't know what the hell this stuff is. I've never figured it out. Or this. This allows you to do ASCII art, like, and this thing here too, right? You can't represent other alphabets, so they didn't even try. They have a couple other math symbols, and they have accents for like French and German, but that's about it. There's barely any Greek up here. It's not the full Greek alphabet. They knew they couldn't represent everything, so they did some math symbols as well. But if you want to do anything fancy, you need to use Unicode. ASCII, by the way, ASCII images, old school, way before your time. We used to actually try and do drawings with a bunch of characters, and that would form an image. So you could actually make a picture of Homer Simpson just using, let's say, all of these ASCII characters in a row. It's a very old art form that's really nerdy. So here's our ASCII table again. Most of the time, you don't need to worry about it. You need to know A to Z is contiguous. It actually starts at 65, but you don't even need to memorize that if you're smart about it. Lowercase a to lowercase z is from 97 to 122. All your ASCII characters, the numeric characters 0 to 9 is 48 to 57. Fine. But you don't need to know what those numbers are. You will never need to necessarily go, what is the ASCII value for 3? I could just be, intelligent about it and say the character 0 plus 3 is the ASCII code for the character 3. Okay. And I can compare these things. So I can say, is A less than B? Yes, it is. It has a numeric value 65. B is a numeric value 66. It still works. The numeric value 1 is less than the numeric value 2. The uppercase and lowercase, however, are different. Lowercase letters are higher on the ASCII table than uppercase. And so lowercase a is actually greater than uppercase z. I think that's a bit counterintuitive for a lot of, and it is for a lot of people, but that's the one little gotcha along the way. You can't compare upper and lowercase values. You have to convert it to one to the other. You convert them all to lowercase and then compare your characters. You can't compare an uppercase and a lowercase character and have it really make sense. You can do it, it's just you'll get the wrong answer. We even have some little helper functions along the way. So if you include cctype.h, it's a header file, so include cctype.h in the angled parentheses. You can type in things like is alpha and put in a character C, and it returns true if it's an alphabetic character, uppercase or lowercase. Is alpha? Let me see here. Is it a letter or digit? That's what the L is there. Ugh. I don't like these terminology. Is digit is the one I would naturally go with, but this is an alphanumeric. Is it an alphanumeric character? So is it a number or a letter? Is it a digit? Is it just 0 to 9? Is it lowercase? Is it printable? Is printable or is print? Is punctuation? Is it a kind of punctuation? Is it uppercase? Is it a space, like a tab or the space character? So there's some built-in functions. In fact, you could write those built-in functions yourself just to make sure you have a feel for how they work. IsDigit, you should be able to write the code for IsDigit yourself, your own version of it, and make sure it works. Right? How would you do that? Well, I would take my number, whatever number goes into my function. I then check to see if it's greater than the character 0, and greater than or equal to the character 0, and less than or equal to the character 9. Therefore, it's a digit. That would do it. Right? It's in that range that I'm looking for. So I have an if statement with an and in between. It's in between. It's greater than this, greater or equal to this, and less than or equal to this. Okay. How about we write TOUPPER? And this is going to be a little exercise we're going to do together. Well, I'm not going to do it together. I'm going to go over the answer in a second. Try writing the function TOUPPER. Now, this is a built-in function. We already talked about the fact it's is upper. There's a TOUPPER where it can convert it. So, but TOUPPER will take in a character, and if it happens to be lowercase, it will make it uppercase. If it's uppercase, nothing happens. If it's a number, nothing happens. If it's a tab, nothing happens. Anything but a lowercase character is left alone. But a lowercase character gets converted to the uppercase character. And you won't need a crazy bunch of if statements. You just really need one if statement. So try this out on your own. Pause the video right now. Try this out on your own as a function, and we'll go over an answer. Okay, let's see if I have an answer here. So I'm going to see if I'm on the, okay, we're going to move on to the next part. So we're going to keep this, and let's look at our answer. I actually already opened this thing up, so here's my string test. I'm going to try my asserts again because I like this. Some people don't quite understand why I do this. Asserting means it allows me to quickly test stuff. Because if this assert was false, the whole thing crashes. Now, that's a pretty ugly way of testing it, but it does in a pinch if I really need it quickly. So if my function is working correctly, what I would expect is if I pass in the character A, I get an uppercase A. What I should probably do is try another character as well. So let's do Z, or let's do Y. Something that's a bit more off the beaten path. Okay, if it's an uppercase character, I expect it to return just the same uppercase character. Same with a number, same with punctuation or spaces and that sort of thing. So before I even wrote my function, I made my tests, things that I would expect to see. Even if you don't put the assert in there, you should think, what does my function do? Okay, how does it work in these various cases? What are the various situations that I have? I want to think through my code before I start coding. I want to think through my algorithm first. Okay, so what's my algorithm? My algorithm is going to be, I'm going to look at the character. I'm going to see if it's a lowercase character. If it is a lowercase character, I'm going to do some fancy, the easiest thing would be to do some fancy math. So I figure out how far from lowercase a it is, which is exactly how far from uppercase A it should be. So if I go, let's say the character C, or I could say A. Character A minus the character A is 0. If I add 0 to the uppercase character A, I get the character A. If I have C, it's the character C minus the lowercase character A. That's 2. And if I add 2 to uppercase A, I get uppercase C. So I can actually avoid all of this, like, oh, on this tape, I don't need a switch statement with 26 different characters. I just need, is it in this range? Okay, do some math. Now, I could do it with a switch statement, but I don't want to write that much. That's a whole lot of writing. I'm lazy. Okay, so let's have a look at this thing. Here's TOUPPER. It takes in a character C. If the value is greater than or equal to A, and the value is less than or equal to Z, that's what we expect. That's in the range that we need it to be in. Then I take the character that I have here. I could call it char or some other value here. I take the character that I have here. I subtract the character A from it. And then I add the character A to it. And so it should automatically change what I have here. Right? So if I have C minus A, lowercase c minus A gives me the value 2, plus the character A, which is now the character C, and that's what I'm returning. Otherwise, don't do anything at all, just return the character I had. All right, and if I compile it, it should already be compiled, I think, but okay, I now compiled it, and I'm going to put a character return right here just because I know what I'm going to have a bunch of other stuff afterwards. Oh, I put it in the TOUPPER. Okay, so let's see. What do I have for character? A minus A 0 plus capital A. That should be returning the value capital A. I don't actually need this part. Let's see. Okay, I went through all my asserts. Nothing failed. Everything worked. Nothing exploded on me. Therefore, this must be working as I expect. I'm going to just stop it there because I have a bunch of other code that's in my program. But when we come back next time, we've just taken our step into looking at characters. When we come back next time, we're going to be looking at strings. Can I make an array of characters and deal with text? Okay, thanks everyone. I'll talk to you soon.